Hello there, welcome to your 8th webinar. In this webinar, we will talk about everything that you need to know to build your own sequence-to-sequence model. More specifically, we will code along the text summarization model, which as an input you will give any length of document, and as an output it will give you the summary. And the reason why we want to use sequence-to-sequence model instead of using a simple RNN model or simple LSTM model is because in sequence-to-sequence model, we can input any length of the document that we want, and as an output, the summary can be any length. But in a simple RNN or simple LSTM model, the number of input sequence and number of output sequence should be always the same. That is why in here we want to build a sequence-to-sequence model instead of just LSTM or RNN. And this sequence-to-sequence model is can be used in a lot of tasks. Like the first one is text summarization, then is machine translation, and also you can use it in chatbot and so many other tasks. So in here we will use a dataset called Amazon Fine Food Review, which if you click on you can download it. It will take you to Kaggle, and this dataset more specifically, if you look at the last column, you'll see the text, and the other column it shows the corresponding summary, which we want to link this text to its summary. And you can go on and click on download, and after downloading it you can start the code. So let's start by importing the pandas. Now let's load the dataset. We will call it reviews. And for me, I put this dataset into a folder called dataset, and the CSV that we want to use is called review.csv. So let's also take the head. Okay, it might take a while because the dataset is around 500,000 training examples. So let me also get the shape. So while this is, as you can see, it loaded. So now let's get the shape of it. You can say print shape of the data set reviews dot shape. And as you can see, this is around 500,000. It's a pretty large data set. So now let's delete all of the null values inside our dataset. So we will say reviews is equal to reviews and drop NA, which it will drop all of the null rows. Now let's also remove all of the irrelevant columns because we only want to use this text and its summary. The rest is absolutely irrelevant. So we can call reviews dot drop, and inside drop we will define a list with the columns names that we want to drop. The first one is ID, then it is product ID and user ID, then profile name, then helpfulness numerator, then helpfulness denominator, and score time. So now we only have these two columns, and at the end we want to also reset the index because since we delete some of the rows, the index going to be a little bit inconsistent. So we want to reset it so we have actual indexes. So we can say reviews reset index. Now let's take a look at it again. That head. At the end, also have to define the axis of 1. Okay, now as you can see, we have summary and text. So the second part, after loading any type of data set, we want to apply this pre-processing, which is literally the same thing if you want to approach any type of NLP tasks. More specifically, in here we will apply 6 steps. First, we will lowercase the text. Then we will remove all of the punctuation, like question mark, dot, and this type of thing. Then we want to replace the contractors with their longer form. What does this mean? For example, something is like your. We want to convert it to you are. Or if there's something like she's, we want to convert it she is. Or if it's his, we want to convert it to he is, and etc. And for this we use a library. You do not need to worry to actually write it down, every single one of them. At the fourth step, we will tokenize the word, which we will split the sentence into words, and we will remove all of the stop words inside these words, which stop words are the words that appearing the most, which it will not make sense. Then we will convert this list of strings or tokens into one string again. So before anything, go on and install this library. It's called contractions, which it will do the job for you for the step 3 automatically. So for me, I already installed it, so it will not show anything. So before writing down the function for our pre-processing test, let's import some libraries that we are going to use for pre-processing. At the start is a regular expression. Then we use NumPy. We also use Pickle for saving. We will also use this contraction that we have just created. And also we will use a tokenizer from Keras, which is Keras preprocessing. Processing the text import tokenizer. And also let's import the NLT case tokenizer. And also let's import all of the stop words. And lastly, let's import library from the Keras for padding with zeros. Processing that sequence. Okay, this is all of the libraries that we are going to use for pre-processing. Now let's start by writing down the function. We will call it pre-process, which as an input it will take a text, and also we want to specify to remove the stop words or not, because for the summaries we don't want to do it. So by default it is true. So as we said at the very start, we want to lowercase the text, which you'll say just text equal to text.lower. And as a second step, we want to remove all of the punctuation, which for removing the punctuation we will use the regular expression library. Then inside this we can define okay, we want to say keep all of the lowercase alphabets, and also keep all of the uppercase alphabet, and also keep all of the numbers. If you found anything else, replace it with empty strings. And we want to apply this into our text. So the third step is to replacing the contractor with their longer form, which we have already imported library. So let's say text, and we use these contractions, and we want to say fix, and then we put our text. Now this will replace all of this contractor with a longer form, so you do not need to be worried about anything. The next step is to tokenize the word. Say tokens. Word tokenizer, and we will apply it into our text, which we will get our tokens. And the next step is to remove the stop words. Remove the stop words. And in here, since we want to specify whether remove it or not, the user have to specify it. So we will say if remove stop words, then remove all of the stop words. We say tokens. We will define a list. We will say for I token in tokens. We want to say iterate through these tokens, and the token that we are already in that iteration, if the token is not a stop word, then keep it. Stop words dot words English. Then keep that word. And as a very last step, we want to convert the list of strings to one string. So convert the list of strings into string, which we will do simply by saying empty strings dot join. It will join all of the strings inside the list into just one strings, so tokens. Then at the very end we want to return this text. Now let's apply this into our text and summaries. We will define a list for it. We will say iterate through reviews. In reviews, which we want to take this column, iterate through each of this review, and then apply this pre-processing for it. We want to also do the same thing for our summaries, which will define a list, and we will iterate through our summary column. Which the summary column is this. So let's iterate through each of it, and then we will apply the pre-processing to this iSummary. And also it's very important that we want to specify that we do not want to remove the stop words here. So we will say false. So since we have a 500,000 dataset, this pre-processing might take a while. So I have already created it. So after, I will also write down the saving, how to save this. After that, I will load, so it will not take any time for you to see this lesson. For saving the dataset that you have already pre-processed, you can first create a list. Then inside that list, you will append the dictionary. Let's actually start by doing it. So at the start, we say pre-processed data. We will define a list, and then we will iterate through our text, this text. Then we will say this preprocessed data. We want to append the dictionary, which the first one is going to be text, this IA text, and also we want to put this corresponding summary, which you can do it simply by saying summary here, and then define this index that we define. So in here now we are ready to save it with our pickle. For with pickle we'll say just pickle.dump this preprocessed data, and then you will say open dataset preprocessed dataset. I have already defined it. You can define something like a name for it, and then you will say WP. So now this will save all of this preprocessed data. So later on you will not need to run this, so it will take a while if you do not have a very strong computer. So now let's load the pickle that I have before I created it. Process data, pickle. This time we will say load, and inside this load we will say open and put this data set, and also it was called preprocessed dataset.pickle, and since we want to just read it, we will say RB. Now let's also print out the length of the loaded dataset. Length of dataset, I will say length preprocessed data. Call it something. So as you can see, it have already loaded, which is the preprocessed version. So now that we have loaded, now let's, after getting this pickle, we want to again get this form, like a text with a list and summary with a list. So let's get all of the text and summaries from this pickle that we have already loaded it. And we'll say text. We'll say for I in preprocessed data, and get the text. Want to do the same thing for the summary as well. We say this, but instead I.summary. Now this will get our text and summary in no time. And since in here we just want to do everything at the start just a little bit speedy to create our model, it's always a good idea at the start to take a subset of your data set so you can finish everything, and at the end, if everything goes well, you can use all of the data set. This is a great trick if you want to finish your stuff faster. So instead of 500,000, let's say we want to get only 8,000. Now let's take the subset of it, subset amount, and also for summary we want to take until subset amount. So now let's also print it. Print length of dataset. Which, as you can see, we only now have only 8,000, which is very small, corresponding with its original amount. So now let's vectorize our data. So at the very start, we will initialize empty list for our text, input text, and also target text. We'll say input texts, empty bracket, target texts bracket, and also we want to initialize an empty list for characters, which is just this alphabet and numbers. Input characters, which is a set, since we do not want to repeat it. And also target characters, this is a set as well. Now we will want to iterate through text and its summary. We will say input text, target summary, and we will make a zip, which we will iterate through text and summary. And at the start of the iteration, we want to add this tab at the start of each sequence, and also this /n at the end of each sequence. This is necessary. So we will say target text, target text, we will dash t, then we will apply this, then also dash n at the end. Now let's append the text into this input text and target text. Input texts, let append input text, which is this, and also target texts, append target text. So now again we want to iterate through this input text, so we can get the characters, so we can append it to this input characters. We will say it for character in input text, which is this input text. Then you will say if character is not inside the input characters, then we can add it. Oops. Again, we want to iterate through, this time to the target text here, or character in target text. If character is not inside the in target characters, then add it. Okay, great. Now let's get the input and target characters. So input characters. So you will say input characters, but first we want to take a list of it, and then we want to sort this list. We'll say sorted. We'll do the same thing for our target characters. Okay, great. Now we have our input characters and also target characters. Now let's get the number of tokens which is inside each of this encoder and decoder. You can say call this num encoder tokens. Then we will take the length of this input characters. You'll do the same thing for decoder, which is target characters. Okay, great. So now let's also get the maximum length of each encoder and decoder sequence. We can call it maximum encoder sequence length, which first we will get a list. We will iterate through this input texts. Then we will take this length of it, and among this length of text which is inside the list, we want to get a maximum number. We will do the same thing for our decoder, but instead of input text we will do it in target texts. So now our vectorized data is ready. We can also print out the results, so it will be more specific for us. Number of samples, take a length of input texts, print, we can say number of unique tokens, which is number of encoder tokens, then number of unique input tokens, output tokens, which is the number of decoder this time tokens, also maximum sequence length for inputs, which is this max encoder sequence length. Also same thing, but for outputs is maximum decoder sequence. So in here we can see that we have already 8,000 samples or dataset, and number of unique input tokens are 37, and number of unique output tokens are 39, and the maximum length for input is around 3,500, and the maximum length for our output is 120. So now let's create the input and target token index. Call it input token index, which is a dictionary, and inside this dictionary we are going to have a list which will iterate through a character. We will numerate, we will iterate through this input characters, and here we're gonna have a tuple. Inside this list we will get the character and its corresponding index. We will also do the same thing for our target token index, which the only difference is going to be this target characters. So now let's initialize 0 matrices for our encoder input data, decoder input data, and also decoder target data. These three things is what we are going to put into our model. So in sequence to sequence model, we need the input to our encoder, input to our decoder, and also the target decoder. So let's initialize it with 0, which later we will update it. So we will call this, let's say, encoder input data, which we will initialize with zeros. And in here we will take the shape of first length of the input text, and then we will take the maximum encoder sequence length. Then we will get the number of encoder tokens. Great. Now let's do the same thing for this time decoder input data, which at the start is going to be again input texts. This time is going to be maximum decoder sequence length, and at the very end is going to be number of decoder tokens. So very great. Also, I forgot to specify the D type as well in order to avoid any problem. So the D type should be float 32. float 32 and also float 32. And lastly, it's going to be decoder target data, which the shape is going to, instead of in here, we'll do maximum decoder sequence length, and this is going to be also number of decoder tokens. So this decoder target data and decoder input data, if you notice, they're going to have the same shape. So now let's update them before we put this into our model. This is the last steps we need to do. You will say for I or index, and also input text. Okay. Input text and target text, in enumerate, also zip, since we want to have enumerate in two things. It's the input texts and also target texts. Again, we will iterate through this, so we will get the character, enumerate input text, say enumerate input data, and in here we want to take this index at the start, then we want to take this t, and then also input text index, which we're going to take this character, and then we will make it equal to 1. Again, we will iterate through the character in enumerate, but this time it's going to be target text, which we are going to get decoder input data. At the start, we want to take this in the I, then this T, then target token index, which we will get from this character, then we will make it equal to 1. And we want to say also if this T was larger than, it was bigger, greater, or equal to 1, then in that case also we say decoder target data, we'll get this I, and also, but this time t minus 1, because this decoder target data is literally the same thing as decoder input data. The only difference between these two is their time step. Like decoder input data is one time step ahead, and decoder target data is one time step before. That's the only difference that these two have. So we will call this target token index. We get the character, then we'll make it equal to 1. That is it. Now we are totally ready to put these three data into our model. Let's also get the shape of it. Decoder shape, print decoder input data shape, also decoder target data shape. So this is the data we are going to put our model. Very great. Now we are ready to build our sequence to sequence model. So before we write the sequence to sequence model, let's import all of the libraries that we are going to use. Say Keras, layers, first input, then elastine, also embedding, and also tense. Models. Also, let's cast losses. Import the categorical cross entropy, and let's also import the optimizers, which we are going to use Adam. And let's also import the Keras callbacks, which we are going to import the model checkout checkpoint. And also lastly, let's import Keras, from Keras import the utils, and also import the matplotlib at the very end, which we are going to plot the actual model. So as plt and also matplotlib inline. Okay, great. Great. Now let's start by writing down our sequence to sequence to model. So a sequence to sequence model, we are going to have an encoder, which it will take the input data with any length. Then this encoder, after encoding the data, it will make a context vector, which it will give this context vector to our decoder, and this decoder gives the output sequence that you want. As I said, this is very great if the amount of your in the size of input data and also target, they're very different. This sequence to sequence model is great for that. So let's write down the function for it. We call this sec to sec, which it will only take the input size and also output size, and also number of units for our LSTM. At the very start, we will make our encoder, which like encoder, like all the time we are going to have an input. We have to define the input. This input will take a shape which of none and also number of inputs. And encoder, then we will define LSTM for it, which number of units going to be this n units. And also in here, it's important to notice this is going to be a little bit different. So in here we want to, here the return state is false, which we want to return the state actually, but we don't want to return any sequence. Let's write this down. We don't want to return any sequence, but we want to return state. So let's also say encoder output, which in this return encoder output, in here we want to compute this, which if we compute this, it will give us first encoder output, and since we put this return state to true, it will also return two more state, which is state S and state C. If we didn't return this state, we will not have this, which we say encoder inputs. And lastly, let's also put this encoder states into a list. So now our encoder is absolutely ready. Let's now also create a decoder. Which again, we're in here, we're going to have a different inputs. But this time the shape is going to be number of outputs, because decoder is after encoder. So after defining these inputs, we will also want to define LSTM. LSTM units. Okay, in here, unlike this LSTM encoder, we want to return the sequence as true, and we also want to return state as well. True. Okay, very great. So in here we'll take the encoder output. We don't want to, okay, decoder, and inside this decoder we will take the we will take this decoder inputs, and also we want to say the initial state is this encoder. Okay, great. Now let's define a dense layer, which the number of units is going to be the n outputs. And also we want to use the activation of the softmax. Now let's get the decoder output, which is going to be this decoder dense. Oops. Okay, great. Now we have created our encoder and also our decoder. Now let's create this sequence to sequence model. Create the sequence to sequence model, which we want to stick this together. We'll call this model. This model as an input, it will take these encoder inputs, also decoder inputs, and it will return decoder outputs. And now we have created this simple sequence to sequence model. And for inference, if you want to make any prediction, the model is going to be a little bit different. So we will create them here as well. We call this inference model. We call this encoder model, which the input is going to be encoder inputs, and the output is going to be encoder states. Also inference decoder. So in here for inferencing decoder, at the very start we will initialize two inputs, which one of them is going to be for this state H, and another one is going to be for state C. So let's say decoder state input H, which the shape is going to be the number of units. We want to have another input, but this time for decoder C. Okay, the dimension should be true. Now let's write down decoder states input, which we put these two inside the list. So now let's say decoder output state H and also state C, which we're gonna do this decoder, and as an input we are going to get a decoder input, and also as an initial state. This time we will get this decoder states input. Okay, great. Now so also decoder states. Let's record this state as well. Also decoder output, which is model, which as an input it will get a decoder input. Plus this decoder states. And as an output we will take decoder output, also decoder state. Great. Now also we will return three things. First, this sequence to sequence model, which it will be used for training. The second one is going to be encoder model, which is going to be for inference. And also the lastly is going to be decoder model, I forgot to write down the decoder output. Decoder dense. Which it will take decoder outputs. Okay, great. We'll take this decoder model. So now our sequence to sequence is ready for training and also for both inference. Before we defining the model, let's write down the number of features we're going to have, number of input states, and also number of output states. For number of features, we can say encoder input data. We'll get the first one, which if you look at it, is going to be the total number of our training examples. The number of inputs is going to be encoder input data, but this time, we're going to take this 37 and number of steps output is going to be decoder target data, which we're again going to take the last one, which is 39. So now let's initialize the model, which is going to be the sequence to sequence model, and it will return first model, encoder model, and also decoder model. This model is going to be for training, and this two is going to be for inference. For the number of inputs, as we can define it here, number of output is number spits out, and as a number of units we can say 256. Okay, number of inputs. Okay, let's see. Okay, it ran correctly. Now let's also compile the model. For optimizer, we use Adam that we have just imported it. You can define learning rate like 1e minus 3, which is going to be 0.001. Also, let's define a loss function, which in here we're going to define a categorical. We call cross entropy. And let's take the summary of our model. Okay, great. As you can see in here, we're going to have two inputs, two LSTM, and also one last dense layer. Now let's plot this summary that we are just seeing it. For plotting, Keras actually have a library which I have already imported it for utils, which with this you can show the model actually. Say utils.plot model. You will take this model, and also it will save to a file. You can say assets model.png. Now this will save this shape into this directory. Now with Matplotlib we have to read this and then we will show it. We call this model image plt.imread, which will take this directory, and also let's define a size for it. We say figure fig size of the 7 to 7. And now let's show it. I'm show model.ing and also show. Okay, great. As you can see, we also have the visualization of our model as well. So before fitting the model to our dataset, let's define a checkpointer so we can actually save the model with it. We will call this checkpointer, and we get the model checkpoint that we have just imported from Keras. Now in here we have to define a path, which we can say saved model, and for the name we will say weights.best.text summarization, and the format is going to be hdf5. And we put the variables for 1, and also we want to save the best only, which only if our model got a little bit better at each iteration, in that case it will save it. So now we're ready for training the model. Let's say model.fit. As an input we will take our list of encoder input data and also decoder input data, and as output we will get a decoder target data. Now you can also define the other hyperparameters, like batch size of, let's say, 42, and also epochs of 10. Let's also call the validation split, so we can also see the testing. We can set 20%. And lastly, we also have to define this check pointer that we have just created it. Great. Now our model will start the training. Again, this model is not going to be perfect because we are only training on an 8,000 dataset, which the original amount was 500,000. For sure, if you train it with 500,000, you're gonna reach a very great result. Still, this is for testing. So now I will pass forward this, so the training will be finished. So we will go to the prediction part. Okay, now the training has been done. Let's take a look at the result. As you can see, we had 10 epochs, and at the very last epoch, we reached to a loss of 30%, and also around 30% for the validation as well. So now let's go to the last part of this webinar, which we will, now we train our model, we are ready to make a prediction. However, before we do the prediction, we need to do two things, and then after that we can make prediction on any type of unseen datasets. At the very start, we have to make a reverse lookup table, lookup token index, which we have created so far, the lookup token index. Now we want to make the reverse of it. So let's call this reverse input character index, which this is going to be a dictionary. And inside this dictionary, we will get character and index at each iteration, and we will iterate through the input token index items. And in here, at each iteration, we want to get index and also the character. Very well. Now let's repeat the same thing for the target. So we will call this reverse target character index, which in here we only will iterate through the target token index. Okay, great. Now let's start writing a function called decode sequence, which we will use this for our prediction. So let's write it down, decode sequence. In here we will take three parameters. The first one, the input sequence that we want to predict. The second one is the encoder model that we have created in here. We want to take these two. And one thing else, while we're fitting this model, also the weights of these two, encoder and decoder, has been changed. So let's put encoder model and also decoder model. At the very start, we will encode the input as a state vector. So let's say encode the input as the state vectors, state values, we call it. Then we take our encoder model and we predict the input sequence that we got in our function. Now we will generate empty target sequence of length 1. Okay, let's call this target sequence, which we will initialize it with zeros. It is going to be 3 dimension. The first two is 1 dimension, and the third one is going to be the number of decoder tokens, which we got it in here, number of decoder tokens. Okay, great. So now that we have generated the 0 targets, now let's update it so we can add the first character target at each iteration. Let's say populate the first character of target sequence with the start character. So we will get this 0 0, we don't mind. So in here we want to get the target token index, and we want to put this starting at, which is the /t, and we'll make it equal to 1. Great. Now we want to let's write this down, sampling loop for a batch of sequences, which in here, for just simplicity, we will consider the batch of 1. Okay, let's initialize a stop condition since we are going to have a loop. False. So decoded sentence empty strings, and later on it will get filled. So now let's make the while loop. We say while not stop condition. We say output token. And also the state H and state C is equal to decoder model here, which it will predict target sequence plus state value. Okay, great. Now we made the prediction. Next, we want to sample a token, which we will say sampled token index, and we will get the argmax of it, argmax of output token, and we'll say 0, the last one, and all. Okay, great. Now in here we will get the maximum, and then we'll say sampled character, get the reverse target character, and we'll say sample token index. Then we will say to decoded sentence, which, where is it? A decoded sentence. In here we will add this sample character. Excuse me. Great. Now let's say exit condition if hit max length or find stop character, which is /n. So let's say write this down in the code. We say if sampled character is either reached to end or the length of decoded sentence is bigger than a max decoder sequence. In this case, we will make this true. Okay, now we want to update the target sequence. Say target sequence is equal to, first we will initialize the zeros. The first two is going to be 1, and then is number decoder tokens equal to 1, and then we will update sample tokens index with 1. Okay, great. And lastly, we will just update the states value. We will put this HMC. Then lastly, we will just return the decoded sentence.